Hey, I'm John Taylor here at CeBIT 2011 in Hanover, Germany. We're about to take a look at a demonstration here of the upcoming AMD A-Series Fusion APU, or Accelerated Processing Unit, in contrast with an Intel Core i7 Sandy Bridge-based production shipping notebook. Okay, so let's go ahead and launch over here. I think enter will get me going. Yes, all right, enter over here. So started Intel on the right, AMD Fusion APU on the left. We are starting with the Final Fantasy official benchmark. You'll see, for some people it's hard to see red on black, but both systems are about to begin the process of running through the benchmark. There's a few things to look at. One, what happens with the wattage? Two, how are the two systems performing on the benchmark? This is a very common benchmark used by a number of reviewers worldwide. And then three, in the lower left, you'll see a line graph, almost like a heartbeat or an EKG, that gives a readout over all of the stability of how the benchmark is being run, or when there's been gaps where essentially the benchmark has stopped running. So the AMD system, despite starting later, began the benchmark much more quickly, is running the benchmark much more smoothly. Wattage is similar. AMD system's a little higher right now. Intel system's now spiked higher than the AMD. They'll basically vacillate between one being a little more power than the other, depending upon where they are in the sequence on this demo. Okay, so now every time I hit enter with these identical benchmark scripts on each system, I'll launch a new application. So on AMD and Intel, we will now launch a many thousand-line Excel spreadsheet. So this starts to get at architectural choices. The AMD system, as we've talked about, is a balance in the design between discrete level GPU IP and quad-core x86. The Intel chip, by either die area or design choice, is much more CPU intensive, with a lesser area of the die that's dedicated to GPU. And so now we're engaging that CPU that Intel tends to rely on a little more heavily than the AMD design does with the APU. So our wattage is higher now as Intel has prepared to move on to the next scene and isn't rendering anything. The Excel spreadsheet continues to process in the background. This also, the AMD system started this benchmark after the Intel system has raced ahead on the benchmark. We see the continued stable performance despite x86 being hit heavily by the Excel spreadsheet. The Intel system should get there in a moment. We want to see that character go up the stairs, see how it's performing. Okay, and their wattage as they go into the scene then goes higher than AMD. So let's keep going. Another enter on each side, and we'll launch a new application. So now we're going to begin with the playback of a 1080p video clip. We're using CyberLink on both. With AMD, we're doing some additional post-processing. But overall, this is the beauty of video acceleration. A couple of years ago, launching an HD video clip, a 1080p video clip on either an Intel or an AMD notebook might have caused the CPU utilization to spike. It might have even struggled with that workload. Video acceleration works terrific. It's working smoothly on the Intel system, working smoothly on the AMD system. We'll take a look at what's happening with some of the other workloads that we're asking the systems to perform. We see, the gaps getting a little bit wider on the Intel system. Performance, a little bit of a drop in the frame rates, but performance staying much steadier on the AMD system. Let me mute this for us. Okay, now let's add another workload. Now we're launching Spec View Perf 11.0. The AMD system quickly brought it up while continuing with the benchmark, continuing with the Excel spreadsheet, continuing with the 1080p playback. Instantly began rendering this little Maserati. The Intel system is now struggling with 2 of the 4 workloads. It's struggling with this workload, it's struggling with the Final Fantasy workload. Using video acceleration on 1080p, it's doing okay, and that CPU intensive architecture allows it to continue to work well with the spreadsheet. But if you look at the watts, Intel's now staying steadily at 65, 66 watts. It'll spike above 70, depending upon where it is. The AMD system's really always ranged between about 48 and 55 watts while managing the workloads. Now, the next thing that we'll take a look at is that Windows Vista and then Windows 7 began engaging the GPU to render the user interface. Technologies like Flip, right? It's one of the things that Microsoft delivered that there was a lot of attention on around Vista and Windows 7. Microsoft continues with a lot of its applications like Internet Explorer 9, Office 2010, to now use the GPU to deliver a better, more visual experience. So when I hit enter now on the AMD system, we very quickly move into flip mode, and every 10 seconds it'll flip to a new application. Intel system does not respond quite as quickly. There we go. So now the Intel system flipped. Once it got there, did okay flipping through it, and now roughly every 10 seconds or so, you'll see the AMD system be able to respond to that command and flip to a new application. It'll take the Intel system as it works through these workloads quite a bit longer to recognize the command and make the flip to an additional workload in the foreground. That also, of course, changes the prioritization of how things are being processed. So we're sitting at 55 watts. Intel is sitting currently at about 60 watts. It's got the relief of having an Excel spreadsheet in the foreground. $66 watts to 55 watts. So that's, we've seen a range here of between 15-20% to 25% or higher in the wattage discrepancy between the two, while the AMD system continues smoothly executing the benchmarks. So the takeaways from this demonstration are: one, there's no replacement for true discrete graphics intellectual property. AMD has that. AMD's integrated that in our designs with our C and E series Fusion APUs that are in market today and our upcoming A series APU. Two, if you think about the Sandy Bridge based systems, clearly there's still a very strong argument for the need for a discrete Radeon graphics attached to that system. And then three, just that overall, claims of discrete level graphics performance. We've been measuring the capabilities of discrete graphics GPUs for the better part of a couple of decades. It's pretty easy to understand the real deal from the pretenders.